I'm kicking off a brand new series called Building My Brain, and in it, we're going back to basics, breaking down core developer concepts, and it's not just for you, it's for me too. First up, Object Oriented Programming, or OOP. Well, what exactly is OOP? It's basically a programming paradigm, a way of organizing your code around objects rather than just actions and data. Think of it like using a cookie cutter to instantly make identical cookies, each with its own frosting, color, and the ability to be eaten. The goal is to make code more modular, flexible, and easier to maintain. And it all boils down to four main principles called the four pillars of OOP. And those four pillars are encapsulation, inheritance, abstraction, and polymorphism. Now let's break it down. Starting with abstraction, this points to interfaces and abstract classes. An interface is a blueprint that defines what a class can do, while an abstract class is a class that can't be instantiated but can be used as a template. This sounds just like an interface, but an abstract class provides more functionality as you can implement methods within it as well as add new functionality on top of the template. Wait, I mentioned abstract classes, but what's a class? Well, good question. That's where encapsulation comes in. Encapsulation is the bundling of attributes and methods into a single unit, and we call this a class. Remember that cookie cutter that I mentioned earlier? Well, this is it. Now, what if you could make cookie cutters from a cookie cutter? We touched on this earlier with abstract classes, and that's where subclasses or child classes come into play. These classes basically inherit from a parent class, but have an advantage since they can add or redefine methods. Which brings me to polymorphism, which ties everything together. It introduces the idea of method overloading, which is the ability to have multiple methods with the same name but different sets of parameters. Method overriding, which is the ability to have multiple methods with the same name, but the compiler knows which one to call based on the object calling it. And polymorphic variables, which is the ability to have methods understand what to output based on the type of variables being used as the input. For example, here I have two classes that implement iStartable and a function that accepts some iStartable object. Within the function, the start engine method is called by the object, which we saw was implemented by each class above. We are then able to define the object as either a gas car or an electric car, and the output will be different based on the input. This is the power of polymorphism. Here's a small visualization of everything we just covered. Starting with iDrivable, we can implement this interface in a vehicle class. From there, we can expand on this vehicle class by creating a sports car and a truck. And that's it. We just implemented all four pillars of object-oriented programming. iDrivable demonstrates abstraction, while the vehicle class is an example of encapsulation. We then use inheritance by creating the sports car and the truck classes. And lastly, the act of being able to create these two classes demonstrates polymorphism, as each of these classes can re-implement and expand on what it means to be a vehicle. And that, in a nutshell, is object-oriented programming. This is just the start of the Building My Brain series. I'll be diving into more core developer concepts like data structures, design patterns, and asynchronous programming very soon. So if you found this quick refresh helpful, make sure to hit that subscribe button and don't miss out on the next video. Thanks for watching, and I'll see you in the next one.